What's going on, everyone? We're going to get started in just a second. Can everybody hear me okay? Okay, let me get things set up here. Get rid of that. Get rid of that. Let's make myself bigger. There we go. Okay, so welcome to the stream. Hope everybody's having a good Saturday. The stream topic for today is what we're discussing is we're combining languages for peak performance. So if you have any questions regarding that, of course, I'm sure I'll have some questions after we're done with the stream. But if you have any, now that you know the topic, if you have any questions that you want answered live on the stream, go ahead and put them in the comment section, and I'll answer them here in a little bit. But I want to start with the usual channel update and announcements sort of thing. I got a couple agenda items to cover, and then after that we'll go into a brief Q&A, and then we're going to do some coding where we're going to combine different languages together to kind of create high performing software. And then after that we'll do an additional round of questions, and that will be it. So anything you have, go ahead and put it in the comments, and they will transfer that over to me, and I will answer it if I can. Okay. So as far as the channel update and announcement sort of thing, as you know, we're just about at 200,000. I just refreshed my console here, and it's at 199,588 subscribers. So by the end of today, I would assume we're going to be at that 200. So with that comes a 200 special video. And I am in the process of recording it. It's going to be, I don't know if I've told a couple people on Discord what it's going to be about, but I'll tell everybody here on stream what it's going to be about. It's going to be kind of in a vlog sort of format, but I'm going to do really a bunch of things that are not related to actual programming. I'm calling it Engineer Man Beyond the Computer. So I'll take you through some of the things I do day to day, some hobbies. We'll go take a ride in the car, we'll talk about some things, and it's going to be a completely different video than anything you've seen. It's not going to relate to any coding, but if you're interested in me as a person, if you're interested in my background, if you're interested in kind of how I arrived at this point in my life and career, things I like to do, how I do work and life balance, then you're probably really going to enjoy it, because it's going to be kind of a closer look at more me as a person and a professional than like me as a teacher or a mentor. So I think it's going to be a good video. I think everybody will like it. And I've recorded some of the content already, but it's still going to be probably another few weeks, I would say, before I can get it out. We're still looking at doing a possible tour. Hold on just one second. Okay, sorry about that. So we're looking at doing a possible tour still. We're 500 and 199,583. So we're looking at a couple different places to possibly do an engineer man tour. I'm trying to understand how many people are interested in that and who is near kind of the nearest metros to me. And we're going to try to pick a place that's good for everybody. If there's not enough interest, then of course we're not going to do it, because we don't want to do it just for like 5 people to show up. That wouldn't be that fun. So we're going to try to nail down, an actual legit number of people will go, and then we'll figure out a location and see what happens. But it may happen, it may not. We'll just have to see. Next thing is we have a Engineer Man subreddit now. If you haven't been watching the streams or been in Discord, we have a subreddit, and somebody reached out to me and said, hey, we reserved /r/engineerman, and if you would like to claim it and use it, then you can. So that's what I did. I messaged the guy, and I got that subreddit under control. I asked last stream, what people think we should do with that subreddit. And the staff and we decided that the best use for the subreddit is going to be to collect all of our resources. So we used to have a channel on Discord for all of our resources, and we removed all of those and put them into Reddit. And this is really great because Reddit has really great search functionality. And because of that, you can find things that you need really fast. And Discord also has search functionality, but not quite as good as Reddit. And because Reddit also gives you kind of the rich look at what that particular content is, whether it's YouTube video or just a website or a blog or some documentation, it looks better on Reddit. But the big thing is that on Reddit there's also a comment stream, and that's something that Discord just doesn't have. So that's what we're using Reddit for. We're happy to adjust that as time goes on to determine what the best way to use it is, but right now we're using it for resources. As far as next topic is stream ideas. I had asked last stream, if anybody had any ideas on how to maximize the streams, make them better for you and others, make them more useful, more fun, more entertaining, or just whatever you want out of them. Because I do these for the people, and I want to make sure that they're good, that they're good and useful. And so I had asked, does anybody have any stream ideas? But what I got a lot of is essentially ideas for new videos. I had opened up a channel on Discord to discuss it, and I mostly just got video requests, but that wasn't really the point. So I'm gonna try to reformulate the question to where I actually get some good input on actual stream ideas, because the streams are not supposed to replace a video. I try not to pick a discrete topic. Like, I don't want to do a stream on like Python multiprocessing, because I could just do a video on Python multiprocessing. But like today we're speaking more of like an abstract concept, which is combining languages for peak performance, where we do a number of different things, and it's not limited to one piece of tech. And I'm not doing these streams to like actually instruct somebody on do steps 1, 2, and 3, and then you will achieve result A. It's more like here's sort of an abstract topic, let's discuss it, let's figure it out, and then we can also go back and forth on questions. So that's really the purpose of the streams. So more on that. I'm gonna redo a channel in Discord, and then we're gonna try it again, but I'm gonna reformulate the question so maybe it yields some better ideas. And then the last thing is we got a couple new video ideas coming out. I'm in the process of working up some machine learning videos, and I know it, and I'm doing it because I know everybody's really interested in that. And not only is everybody interested in it, but it's a very important thing to kind of understand in 2019, because over the past like 2 to 3 years, the battle cry has been artificial intelligence, all the things, machine learning, all the things. And that's really what's happening. There's machine learning models for everything out there. So I think it's important that I start at least introducing that into this channel, because it's a common tenet of engineering, and it's very popular in 2019 and beyond. So I'm working on that. The other thing I'm working on in collaboration with Ducky, staff member, or a fellow rather, is some Unity tutorials, and regarding game making. Not only is he a professional game maker, I'm also I'm not at all a professional game maker. However, I am interested in producing a mobile game. I've always had ideas for a couple of mobile games, and it's something that I wanted to kind of bring to fruition. So I think in collaboration with him, we can both make that happen as well as teach people about games. So you can kind of expect that coming, in the coming, I would say coming months. So that's it for the channel update and announcements. Let me look at my questions log here and see what we got. Off topic. Okay. Do one compiler does all the compiling work into a file? I don't know what that means. What framework would you use? So what framework would you use for combining languages? So that's sort of what we're going to talk about today. I'm going to answer that by sort of describing what we're going to talk about. This idea of combining languages is, there's a number of ways you can do it. And this idea of combining languages is either calling other code or taking other code and using it. I'm sorry, taking code in, say, language A and using it in language B. There's a couple ways you can do that. And I don't want to spoil everything, but no, I'm gonna answer that fully. Is there any way to convert the source code from one language, C, to another, Python? So yes, those are generally called, when you go source to source, generally when you go from human readable source to human readable source, that's a process called transpiling, and that's what it would be if you were to convert something like C to Python. And it's I don't know if that's actually out there, but it's much more likely to have a converter from like C to Python or any statically typed or dynamically typed language to another dynamically typed language is generally pretty easy, and that's because you can always remove types, but you cannot always add types. So, like if you wanted to convert, say, like Python code to C code, the problem with that is you don't know the types, and to convert it to C code, you got to know the types. Of course, you could sometimes infer what the types are. Obviously, if you have a piece of Python code that's something like b equals 4, then, well, b is an integer. So you could easily translate b equals 4 into int b equals 4 on the C side, and that would work perfectly fine. But if the value of b was dynamic, like perhaps it took a value from a database or took some response from a web service or something like that, and you didn't actually know what the value is going to be, then that presents a problem, because how do you convert a variable of an unknown type into code that is actually typed? And so that's kind of the problem. So generally, transpiling occurs from a strict language to a not so strict language. And occasionally it occurs from a not strict language to another not strict language. That's common in JavaScript. Like CoffeeScript transpiles to JavaScript. But then you have like TypeScript, which is a typed version of JavaScript, which again transpiles to JavaScript. But there is no nothing usually converts from a dynamic language into a more strict language. Is there any tool for transpiling? Yes, there are. Generally, if somebody writes code that's designed to transpile to another language, they will also provide that transpiler. So, like in the TypeScript case, there's the TSC CLI tool, which is designed to convert TypeScript into JavaScript, and that's true of anything that provides a transpiling mechanism. Can we expect a video on WebAssembly from your perspective? Yes, I think that's an important thing to do, and I think you can expect that in the future. Yes. Some guy in Sandy, will you be discussing moving data from one program to another in real time? Yes, I will. Actually, in this video, I'll be discussing that, on how to both use other functions, but also how to transfer data from one place to another. which languages you want to combine. So what we're going to be doing in this video is we're going to be using not so high performance languages, but call out to high performance languages for the things that need it. So that's all I'll say right now, but we're going to get into it in just a sec. Okay, I think that's about all I see for now. I'm gonna let some more questions accumulate here, and I'm gonna move on to the actual main content, and we're gonna actually write some code. But first, we're gonna talk about sort of this idea of combining languages. The reason this is important is that each language, generally speaking, is either really fast and really difficult to write, a long development time, or it's really slow. And when I say really slow, I mean relative to, it's not slow. There's really no such thing as a slow language. It's just slower relative to fast languages. That's all. Today in 2019, there's so much processing power that even the slowest language in existence still seems quite snappy. So we're talking about relatively slow. And usually you have very quick languages, over here, which are usually difficult to write. Of course, the fastest of which is just assembly, but that's, of course, extremely difficult to write. The next step away from assembly, of course, is C. C is also very difficult to write. You have to write a lot of code to do things in C that would otherwise take just a couple lines in Python. However, you get top-notch performance with C, but you get a longer development time. So if you shift all the way to the other end of the spectrum, now we're talking about languages like Python, JavaScript, Ruby, PHP, languages like that are really easy to write. You can do a lot of things with not a lot of code, but they'll never execute as fast as their C counterparts. And that's due to a couple things. Number one, with a dynamic type system, meaning you don't actually have to specify what the type is up front. So like Python, you could just do a equals 1. You don't have to do int a equals 1 because Python has types, but it doesn't require you to specify the type up front. And this has an important implication. When you use languages that don't have types up front, it implies that that language will never be able to compile down to machine code. It can at runtime, but it can't at the time you write it. So that's an important implication because non-compiled languages are automatically going to run slower than compiled languages. Because with C, you're able to, in C, C++, also Go, you can take these languages and you can compile all the source code down into machine code, and you just totally remove the target language away from the situation entirely. And this makes it run a lot faster. Anything that's running as an executable runs a lot faster than code that needs to be interpreted, such as Python, JavaScript, and PHP. So the purpose of combining languages is to say, well, do we really need to write everything in C or C++, and do we really need to write everything in JavaScript? And the answer is no. Good applications will use the strengths of each language to its advantage in that code. And that's what we're discussing here today. So what we're going to do in this video is we're going to take high-level languages. I shouldn't say high-level because really everything's high-level these days. But dynamic typed languages, we're going to use JavaScript and Python. And we're going to use JavaScript and Python to call out to C, C++, and Go code. And that's a way of taking, doing routines that need the maximum performance, but also still using JavaScript for the majority of your application. So let's just jump into that. Let me get rid of this here, make myself smaller. If you have any questions as I'm going, put them in the chat, and I will answer them. Whack. Thanks, Doc. Appreciate that. Thanks for the 10 Canadian. It's very nice of you. Is there any problem if the two target languages are not in the same category? C, not OOP, and Java, OOP. Not at all. That's perfectly fine. I should probably mention that. Actually, thanks for bringing that up, because that brings me to another point. Most languages that can compile down, that also implies that you're removing that code. So like when you take C code and you compile it to machine code, the machine code no longer has any knowledge that this code was ever in the C language. And this is an important, this has important implications because it means that that code is now generic. Basically like C code, C++ code compiled down to an executable, it might as well have been some other code compiled down because there's no remnants of the original language in there. And what this means is you can use these languages to create reusable object code. And when you create reusable object code, you can use that in other applications, and that's what we're going to do today. So let's just jump right into that. We're just going to jump right into what's called foreign function interface. And this is the actual mechanism that's involved with using dynamic languages and calling out to low-level object code. So we're going to start by showing my editor first. Oh, not that one. That's old. Okay, here we go. Let's go. So we're going to start by making a piece of C code. So new folder, C. Do a file called main.c. And what we're going to do is we're going to make some C code that we're going to use in Python. It's going to be really simple. We're just going to start with, we're going to do our include standard.io.h. We're going to do our usual void main. And because we're going to be using code from this program in another program, we don't actually need anything in main because we're not running anything in main. The intent here is we're trying to expose functions to be used in another application. So in this case, we'll do like void hello, just really simple. I'll use printf to say like, hello from C with a new line. And this is kind of that's it for that program. This is going to be now hello in this case might be like really high performing code. Just pretend that this is some like 1,000-line highly optimized C code that you want to call from some other place. And its symbol name is called hello. So what we then do is once we have our C code, we're not trying to make an executable out of this. We're trying to make a shared object out of this. And to do that, we can use GCC to do that. So let me open this up here. So we have our main.c file. If we want to make an actual, first we've got to make an object file out of it. So we can use GCC-C, use the PIC option. We'll specify main.c, and we'll output it as main.o. Now what this gives us is an object file. Now normally an object file could then be linked and an executable be created from it, but instead of that we're going to make a shared object out of this. And again, we can use GCC for that. We can do GCC, specify main.o, we can use the -shared option, and we can output it as a main.so file. So now we have three files here. We have our source file, we have our object file, but then we have a shared object file. And the shared object file we can actually now use in other applications. And this is kind of where we now go and do that. So we're going to start with Python. We're going to use Python to call the hello function that was written in C. Pretty cool, right? So let's pop over to that. So we got our shared object file. We're good to go there. So let me make a new file here called, I don't know, like ffi.py. Oh, and again, I'm going to post all this code when I'm done with it to GitHub, so everybody can run everything I did today, just so you can try it out. So the import that we need on Python is called ctypes. This is an import that we're going to use to actually load the shared object file into Python. And to do it, we simply do something like, C equals, or clib, we'll do clib. So clib equals ctypes.cdll.load library. And in here, it's going to take one argument, and that argument is going to be the location of that .so file. So relative to our current directory, it's going to be /c/main.so. Now at this point, clib is essentially referencing the functions that are in that shared object file, so the hello file. And we can actually just call it directly. So we're going to do that here. So to call that C code is as easy as, and you're probably going to be surprised to see this, but it's as easy as clib.hello. And that's it. So we'll come back over here to our terminal. And we're going to run Python 3 ffi.py, and we get an error because I spelled things wrong. I did C tiles, not C types. Let's try it again. And there you go. Hello from C. Now that's pretty. I mean, it's just a few characters of text, but it's kind of a profound thing that happened here, and that's we were able to execute C code from Python. So you could just imagine with just this one small example, and this wasn't that hard to do, right? I mean, 3 lines of code to call C, and 7 lines of code to make a shared object file, and then 2 commands just to actually make that shared object file. So this is not difficult to do. It's not, it's not like it takes thousands of lines of code to link these two together. So a good use case for this would be if you have a Python application and you need to go do something in a high performance manner where you need C because C is the fastest thing, or maybe there's already existing C code out there and it works, it's stable, maybe it's from a published library and you don't want to remake it in Python. You can just reach out to that code from Python and call it. So But this was kind of pointless, right? Because this is just calling a function. But what if you wanted to give it input? And well, guess what? That's supported as well. So we're going to create another function here called, which one did I do before? I did, yeah, sum. So we're going to do int sum, int a, and int b. In this case, instead of printing out the result, we're actually going to return it. So we're going to do return a plus b. So what we've done here is we're allowing us to supply 2 numbers from Python. It's going to transfer them over to the C code, execute it in C, and then transfer the result back. Now that's really cool, right? So we need to go back into our C file, and we need to redo our... You just rebuild it. There we go. So we got our new shared object file. Come back here. So you'll be unsurprised to learn, or maybe you'll be surprised to learn, that using this over here on the Python side is equally as easy. Now remember, it's returning a value now, so you have to use print. And I'm going to do clib.sum. I'm going to specify 2 numbers, 5 and 6. I'll come over here to my terminal. And look at that, 11. Now that's got to be really cool, right? Because now not only are we executing C code, but we're also providing inputs to that C code. And then that C code is returning us data back to Python, which is really cool because that makes it a lot easier. Of course, if you had to come up with a separate way to actually transfer the data back to the original language, well, that would be difficult. But you're literally using C functions as if they were Python functions, except they're backed by C code. And that function could be as complex or long as you needed. It could call other functions. The point is that you can use it, and it's very easy. So, but let's not stop there. Let's actually make a few others, because this is not limited just to C. It's not only C that can do this. So we're going to make a couple other examples here. And I actually have these pre-made just to save time because we only got about a half hour left. So I'm going to create a new folder here called C++. And then in here I'm going to create a file called main.c++. And then the C++ version of this is essentially exactly the same. The only difference is instead of printf, we're using cout. And then because it's not C code, we have to use extern C, and then we have to provide the function prototypes. And this will tell it that these symbols need to exist, that there's C functions, and that the Python foreign function interface should be able to use this as is. So now that we have that, let's go ahead and go into our CPP folder. Got my code here already. So I'm going to just do the same thing with C++. I'm going to create an object file, and then from that object file, I'm going to create a shared object file. And it's the exact same thing I did with C, it's just slightly different code. I mean, it's basically the same code. That's the C version, that's the C++ version. The only difference is extern and cout. So now that I have a C shared object and a C++ shared object, I can come back to Python, and I can just duplicate these, cpplib, cpp, copy this, and that's that. So now I'm calling out to two shared objects files, one that was written in C and one that was written in C++. So now Python 3, ffi.py, and look at that. Hello from C, 11, hello from CPP, 11. Now that's really cool, right? Because that's two languages that we've used now that we can call out to. But let's go further than that. Let's introduce now Go code. So Go is kind of, Go's new language. I don't know if Pizza's on the stream right now, but he'll be really happy to see this. But Go also allows the creation of, and remember, this is all possible because we're using languages that create binaries at the end. So C creates a binary executable, C++ creates a binary executable, and Golang can create a binary executable. So because of that, any language that's worth its salt can also create shared objects instead of an executable. Why the main function is a shared object? Because I don't think it will compile without it, but I'm not 100% sure. I think you have to have it just to satisfy the compiler. But I could be wrong. Maybe that's not necessary. I'm not actually sure. So last thing we're doing is we're going to create a Go folder, and it's the same thing as what we've been doing. So in the Go folder, we'll do main.go. And again, I have my Go code pre-made, but again, it's simple just like the rest. So we got two functions, hello and sum. We have our empty main. We're importing C and FMT that allows us to print, hello from Go. And that's kind of it. So with the Go code, we're going to do kind of the same thing. Of course, Go uses its own compiler, called Go. And to actually build a shared object file, it's a command that looks like this. Go build output main.sharedObject, and you specify a build mode called c-shared, and you supply the main.go. So when I click enter on that, you can see that it creates me two new things. It creates me a main.sharedObject file, which is kind of quite large, and then also creates me a main.h. And the main.h is interesting because Go is emitting a C header file. And if you've ever watched my videos on header files, you know that header files are used to include in your project to say that this is what functions are available for you to use in your project, and then it tells it that that's where you need to link everything together at the linking phase to create an executable. And then you can call out to those functions and they'll be available. So, but in this case, we're just concerned about the main.so file. The main.so allows us to use those functions that are inside. Now, keep in mind that this is no longer Go code, it's just a shared object file. So, just like we've been doing, it's the exact same thing. Instead of CPP, we'll do Go. And then we'll replace these. Now remember, it's capital H for hello, capital S for sum. And just so you can see it, these all are different. I'll do 6 and 7. Then I'll do 7 and 8. Then now I can run my ffi.py file, and you can see now I get I get hello from C, hello from CPP, and hello from Go. So I'm calling out to 3 different shared object files written in 3 different languages, all considered high performance languages because they're ahead of time compiled languages. And I'm doing it with relatively no code. Like this is quite easy. Now it is worth mentioning that there is some overhead here. Like calling a C function from Python is not going to be as quick as calling a Python function from Python because there is a lot that goes into this and there is some overhead. And you can kind of even see it as you execute it. It's not like it seems instant, but to my eye, I do see a delay. It's not like instantaneous. There is a slight delay, and that's just what it's going to be. You can't do these things instantly. But it's fast enough to where it doesn't matter that much. But the reason I bring it up is because if you have like a 10 millisecond routine in Python and you're trying to make a C version of it that's like 9 milliseconds and you have to execute this over and over, you're probably going to incur more overhead in calling out to the C version than you are to just execute it in Python. So you have to take that into consideration. It has to be worth it to incur this overhead to make that call. Otherwise, it's just pointless. So where you really gain a lot of speed is where your actual time gains are huge. Like if the JavaScript version might have taken 3 seconds, but the C version takes like 100 milliseconds, then that's fantastic. Because now you've seen a drastic reduction in time, and the overhead you incurred by calling out to it is really not that large at all with relative to what it would have been if you did it in Python. Just a sec. I think my chat might be broken. Either that or nobody's talking. Okay, anyways. So that's that. That's the Python version. The one thing I wanted to go into next is I wanted to actually do the JavaScript version, just so you can see that this is not just a, Python makes it really easy, but it's not just a Python thing. We can certainly do it in JavaScript as well. Okay, so we're having trouble with, oh, no, somebody posted. It's going to refresh it here. Okay, it's fine, not broken. Okay, cool. All right, I got a little concerned that something was broken on it. All right, so let's move on to the actual JavaScript version, and we're not going to spend a whole lot of time on the JavaScript version. I just want to show you that this feature is available in other languages. It's not just Python. So we're going to create a new file here called ffi.py. I'm sorry, ffi.js rather. Now the version on the Python side it's a little different than the Python version just because JavaScript does it a little differently. So JavaScript has what's actually called FFI, foreign function interface. And it differs a little bit in that you actually have to specify the signature of the function up front so JavaScript knows how to process it. So like, const clib, we're going to try to keep it in the same sort of manner as we did before, ffi.library. And then here we're requesting the C shared object file. But this is where it gets a little dicey. You have to supply the second object, and you have to specify the name of the function that's being exported, and then what its signature looks like. So you have to say there's a hello function, its return type is void, and it has no arguments. And then you got to specify the same thing for sum. Its return type is int, and its arguments are int and int. So not ideal. It'd be nice if you didn't have to do this, but I understand why you have to. But that's just how it works here. But once you've done that, then it's the exact same thing as Python. It's simply clib.hello, and then print clib.sum, 4 and 5. And this is kind of the JavaScript version, essentially the same. And we can run it real quick to check it out. Oh, I don't know why I did print. That's not a JavaScript thing. Console.log. So you can see it works as well. Hello from C, and then 9, and then the same thing would be true for Go. I'm not going to do the C++. Well, actually, I already did it. I'll just copy and paste it. So the CPP version is basically the same, and then the Go version is also the same, except it's just capital H, capital S. And then our implementation here is the exact same thing as Python. You can simply call hello or sum, and you can specify your argument, and it works great. So that's that. And I can probably execute that. So yeah, those are my JavaScript tests, and those are my 3 outputs from that particular file. So that's FFI. So we could sort of put that to the side. FFI is a way to call. Keep in mind, this only works with code that compiles. So like if you wanted to call Python from JavaScript, this isn't the way you would go, because Python cannot create an executable. Well, it can, but it's by embedding an interpreter. It can't create a shared object file to be used from another language. So if you need to call from one language to another, there's a couple ways you could do it, but the simplest way, of course, is simply to just call it via a system call. So that's the next example I wanted to use. And this is a really short example. All we're going to do here is create 2 files. We're going to create a file called py. Let's do py.py. And in this file, all we're going to do is we're going to make it add 2 numbers and print out the result. So, import sys. Then we're going to print int sys.argv1 plus int sys.argv2. And all this does is take 2 parameters and just add them. And we can test that by going to our folder here. Py.py, we can do like 5 and 6. It gives us 11. 5 and 60 gives us 65. So all is well. But keep in mind that this could be a really long function. This could be an existing Python function that does something more than add a number. But in this case, we're just going to use this as an example. And what we're going to do now is create a JavaScript file to call out to this Python file. So create a new file called js.js. And in here, we're going to use the child process module. So required child process. Oops. We're then going to create 2 numbers, like num1 equals 6 or 5, and then num2 equals 11. And then we're going to use the exec function to actually call python3 py.py, specify num1 space num2, then capture the output. So all that's really happening here is we're just executing that script directly, and we're supplying the numbers as arguments to have it do whatever work it needs to do. And then we're just interested in the standard out here. So we can do console.out. And when I come over here to run js.js, you can see I get 16. Except that 16 is being serviced by the Python code. Now, of course, this is a stupid example because JavaScript is well equipped to, say, add 2 numbers. Again, I can't stress that enough. This exact example is absolutely pointless. But imagine if the Python side of the code had some really complex code or some library that you needed to use that wasn't in JavaScript. You could do so in this way. You could create a Python code that just wrapped all that logic but accepted parameters, from standard in, from command line options that then perform some action. In this case, just adding numbers. So the one problem with this is if you have a ton of information to transfer over to the Python side, this does not work very well because there are argument size limits. It's not unlimited. Of course, you could pipe data into the file, but you can't do it through arguments. Like this cannot be 10 megabytes worth of data as an argument. That's simply not going to work. So the question then becomes, what do you do? And this answers an earlier question I got. How do you send data over to processes? And there's a couple ways you can do it. I wrote up one example for you on this video, but I have a couple other things. Generally, when we're talking about communicating between processes or between files, it's this thing called IPC, interprocess communication. But the principles are the same whether the process is running or not. In this example, we're going to talk about a couple ways to do it. So the first way is a way I like. It's just a simple named pipe. And just so people understand what named pipes are, this is probably going to be something new to you. If everybody's, of course, seen the, like echo A, and then you pipe it to cat, and then you get A. That's taking the standard out of one process and piping it in as the standard in for the second process. Well, this is called an anonymous pipe, but there are these things called named pipes. So we'll do make FIFO, first in, first out. We'll call it like data.pipe. And you can see it. This is a special sort of file. It's data.pipe. It has a P here saying it's a pipe file. And essentially what this thing does is it allows one process to write data to it, and it blocks, and it waits for another process to read from it. And it's really kind of cool. So let me open up a second terminal here. It's important to understand how named pipes work before we actually go into using it. Okay, so I got two terminals here. So on one terminal, all I'm going to do is I'm just going to do cat data.pipe. And you can see it's just going to hang. It's not going to do anything. However, when actually I should have done this the other way. So I'm going to do cat.pipe, and it's just going to wait. It's just going to wait for data to be available. So when I come over to here, I'm going to echo like hello. Then I'm going to pipe it into, I'm going to redirect it into data.pipe. And when I do that, you can see that over here it says hello, which is kind of cool because this is an actual named pipe, not an anonymous pipe. And because of the way these things work, the other thing it's going to allow us to do is send data between a process. Essentially, one process will load up data into that pipe, and it'll just wait. And then the other process can start, and it can just read from that pipe all of the data into the actual system. How do you do that again? Make FIFO, MK-FI-FO, and then you specify the name, and that will create you a named pipe, which you can use to do kind of whatever. And this is if you're not on Mac or Linux, then I don't know how to do this on Windows. I don't even know if they have named pipes. I assume they do, but I don't know actually how to do it, so I can't help you there. So now that we have that all set, let's just create some code. One piece of code is going to write to the pipe, and the other piece of code is going to read from the pipe and do something. So we'll start by the process that sends, which will be our Python file. So again, we're going to use Python to send to JavaScript. So for this particular thing, we're going to send JSON over to JavaScript. So all we're going to do is we're going to do with open data.pipe. Of course, we have to open the pipe for writing because we're going to write some stuff to it. We'll just call it FIFO, or I guess that could have been pipe. Let's do pipe. And then what we're going to do with that pipe is we're just going to write data to it. So we're going to write some JSON. Let's go do a name. Like name engineer man. I think that'll be fine. And then this will open that pipe and write data to it. So just like the other thing we did where, and remember it works both directions. One time I did cat data.pipe and I waited for data to come in. The same thing is true for writing. Whoever touches the pipe first, their process basically blocks. And then the second process to touch the pipe actually takes the data. So in this case, what we can do is we can do Python 3 send. And you can see that that has now sent data to that pipe, and it's just kind of sitting there waiting. And we're just going to let it sit there. We're actually going to let it sit there while we're writing our JavaScript version. So on the other end is the receive. Oops, I spelled that wrong. So on the receive end, what we're trying to do on the receive end is to actually receive that data from that pipe. So we need a couple things for that. We need file system, we need init. Oops. What we're doing here is we're doing file system.open data.pipe. We're specifying the read-only option because we're just reading from it. And what this does is this gives us a file descriptor, and the file descriptor is going to be a file descriptor into that pipe. So the intent now is to actually load up a buffer with the value that comes from the pipe and then do something with it. So we'll start by creating our actual pipe. We're going to use net.socket to do so. And we're going to specify a file descriptor as the inlet into that socket. So now pipe is going to be what we're going to use to actually get the data. We'll create an empty buffer. We'll do pipe.on data. Because of the way streams work in Node.js, you can get data kind of in chunks. So each time data has data, we're just going to append that to the buffer. But once the pipe closes, then what we can do is actually do something with that data. So in this case, we're going to parse the buffer. And remember, because we're sending JSON over here, buffer is going to be JSON. And we're going to parse it, and we're going to output it. So remember, over here our terminal is still hung. It's already piping that data over to JavaScript. And we just need one other terminal. Whoops. So on this side, on the second terminal, we're going to do node receive. You can see that it actually received the data, name engineer man. And keep in mind that this is a Node.js object. It's not a string. And that's because in our example here, we used Python to send stringified JSON, but then we received it on the Node.js side and we parsed it as an actual object. If we didn't want to do that, we could just remove parse from here. And if we repeat this again, you can see this time it actually gives us a JSON string. So this is the actual data that it sent from Python. And this is another way to send. Now you could send extremely large amounts of data in this way. In fact, let's make a slight modification. This will be the last thing we do, and then we'll do 5 minutes of questions. Is instead of just sending a name, let's just write data forever. So we'll just do pipe.write hello. So this is going to infinitely write data to that pipe. And then on the receive side, instead of outputting the buffer, we'll just output end. And instead of appending the data to the buffer, we'll just output the data. So really all we're doing now is we're just streaming data over from Python to JavaScript. So over here, we'll start the sending, and of course it hangs. And then when we go to receive over here, you can see that it's just endlessly receiving data from Python. But as soon as it quits, it kills both ends of it. Because once one side is done receiving data, the other side, broken pipe, it ends. Now what we're seeing here is the actual bytes. What I would actually need to do is do toString. Then we'll just do this again. See, now you're seeing actual hello. And this will just write data forever. And the reason I wanted to do this was just to demonstrate that there are no data limitations in this case. If you want to pipe 12 terabytes of data over, then go for it. There's no problem with that. Okay, hopefully that didn't get too confusing there at the end. I know some of these are sort of abstract concepts, and this is just one way to do it. There's several ways to get data over. The other way is you can just use TCP. I don't have an actual example of that, but that is a way to do it. You could certainly just use plain old networking just to send it over, and that would be perfectly fine. So let me have a look at some questions here. See what we got. Oh, can you assign a unique ID to the data, right, and recall from the ID at a later date? As long as you were to store that data somewhere, you could certainly do that. You can send anything over, and it would actually be customary to send, unique serialized versions of data. That way you can do something with it or store it later. But short answer is absolutely, yeah. Squiddy Squid said, "What's Go code?" I've never heard of that before. Go code, I'm calling it Go code, but it's really the Golang language by Google. They that's sort of their new language that they're kind of bringing about to the community. But the reason I wanted to use it today is people don't often think of Go as a platform to make shared objects, but I wanted to show that you can in fact do that, and it's not just limited to C. Let me see here. Question is, what's the difference between sockets and pipes? So one primary difference is pipe is going to be one direction and socket's going to be both directions. The other thing about sockets as well is sockets can be a file, like a Unix domain socket, but socket could also refer to like a port on the computer where you are doing actual network communication, whereas pipes is more like just a means to get data from one place to another, but that's it. Socket is actually kind of a sort of a broader phrase. It's refers to more than one thing, whereas pipe refers to exactly one thing. Okay, I think that's pretty much it. I don't really see that. Let me just look through the chat here. Make sure I didn't miss anybody. Uh, oh, yeah. So where does Java fall in your FFI passing? So Java has a thing called JNI. I did a little research on this prior to this stream. I didn't actually use any Java in this case because I knew I'd run out of time, and it looks like I did. But Java also supports this in both directions. Is you can call Java code directly in Python with I think it's what is it JNI to Py or J. I don't remember exactly. I just looked at this the other day, but there is a module that allows you to call Java code almost like directly org.java.net. Whatever, and you can execute code like that. But I don't have the exact steps off the top of my head. I'm sorry about that. Is there a common method to wrap an interpreted script into a shared object that you know of? The only way you could possibly do that, I imagine, would be if you were to also wrap the script with a full Python interpreter. I suppose that might work, but that would be really, really inefficient. I don't know of a way. No, Jython is not. That's not the same thing. Jython is Python code that's intended to target the JVM. That's what Jython is. Jython doesn't apply in this case. How can I transmit data from a C# program over to JavaScript just like you do with C? You can. That's a good question. So I don't. As you know, C# is a Microsoft language. There's some support for it on Linux, but I didn't actually attempt to create a. The problem with creating a C# shared object is it's generally Microsoft format, and that requires some special code to run. So I don't actually have that answer, but I'd almost be willing to say I'm 100% sure it's possible, just because. Yes, Py4j. That's it. Thank you. That's the one, Py4j. So if you look up that module, that'll help you call Java code in Python. Let's see, what's the best way to remove? Okay, name pipe. Are name pipes received using standard out? Yes. So typically a name pipe works just like an anonymous pipe in that it takes standard in and redirects it to, I'm sorry, other way around. It takes standard out and redirects it to standard in of another thing. So basically, if you do cat data.pipe, you're waiting for the standard out to come from that pipe. If you redirect data into data.pipe, you're passing it the data that should then redirect to the other process. So it's sort of like whoever uses the pipe symbol whoever reads from it. That's a stupid statement. You know, whoever reads from it reads it, and whoever writes to it writes to it. That's kind of dumb, but that is actually how it works. All right, we're just about done. I'll do one more question. We're 1 minute over, and then we'll wrap up. That's probably going. Is it possible to have bash watch the pipe file continuously for data input from other commands to execute that and then reset to? Yeah, the best way to do that would just be in a while loop, because if you read from the pipe, it's gonna block, and when it blocks, it's not actually using any resources. Like, it's not using 100% CPU or anything. It's just waiting. It's just waiting for data. So in pseudocode, if you were to do something like, while true, do cat data.pipe. But I could actually do it here. Done. So there, infinite loop. So that's an infinite loop where I'm watching the pipe. And then down here, what I'll do is I'll just echo ASDF over to that data.pipe. You can see that every time I do it, it just keeps getting higher. So this is a way where I'm continuously watching data coming from that pipe. And hopefully that answers your question on that. That would definitely be a way to do it. Also, thank you for the $5. I really appreciate that. So that would be a way to do it. You could just do it in an infinite loop, and it just keeps watching that pipe and does things with it. So easy peasy. Okay, so finally, I'll just do my kind of end of stream thing here. If you're not on our Discord, of course I gotta pitch our Discord. If you're not on our Discord, you should definitely check it out. Somebody will post a comment with the link here in a second. There's a lot of, we're just about at 5,000 people, with about 10 to 20% of that active at any given time. There's always a lot of discussion going on there. There's a lot of smart people on there, really smart staff. I'm also on there if you ever want to drop me a line and say hi. I do interact with everybody on Discord. I don't avoid people. I don't block DMs. I just ask that that you just be respectful. That's all. But I hope to see you there. It's a good time. People are learning stuff all the time, and I think you'll find that it's one of the cleanest, clearest, best curated programming discords on the face of planet Earth. I'd be willing to say that. So definitely check it out if you haven't already been there. And then be on the lookout for that 200K that's coming within the next probably 6 hours, I would say, is all it should take to close that out. And then be on the lookout for the 200K special, which for sure is coming soon. I'm already recording content for it. It's such a different video that it's content that I'm going to record at various points over a long period of time versus versus a video that I'm just going to sit down and do like I do on Sundays. So, and then of course we got the typical Sunday video coming tomorrow. I don't know the exact topic yet, but I will. You'll know when it comes out for sure. Other than that, thanks to all the regulars who keep coming to the streams. I appreciate it. Keep coming back and keep learning. That's the most important thing. And of course, a special thanks to my entire staff and all the fellows for helping me make all this possible. Because can't do it without you. It'd be impossible to do this. So hope everybody enjoyed the stream, have a fantastic rest of your weekend, and I hope to see you on Discord. Be on the lookout for the video, and take care. We'll see you around.